Globally, 2/3 of us experience severe water scarcity for at least 1 month out of the year. And in 5 years, half of us could be experiencing severe water scarcity full time. There are many issues kind of involved with meeting our needs for water, but one of those is that 70 or 97% of the water on this planet is locked up in our salty oceans. So densely populated and drought-prone areas like California and Northwest Africa are unable to use the seawater without spending a very large amount of energy to separate the water from the salt. At the same time, our oceans carry enough energy to supply 1/10 of the total energy we consume on this planet in the form of ocean waves. My research is considering using that energy in the ocean waves to power, to produce fresh water using reverse osmosis. Reverse osmosis is an efficient method of desalination. It relies on pressurized flow over a thin membrane. That membrane allows water molecules to pass through, but prevents the salt ions from passing. It's efficient, but it requires a lot of energy. Using for wave energy, it's very difficult to drive an electric generator without incurring a lot of energy losses through intermediate steps. But it is easy to attach a pump to a wave-driven device like a buoy or a flap and produce a pressurized flow. So we can couple these two systems relatively easy. A challenge for these systems, though, is that wave energy is highly variable. It's variable in the short term, with each wave having essentially random size, and variable day to day, month to month, with the waves generally having more or less energy in them. To address the short-term variation, I've designed the system a lot like the suspension on your car, where the waves act like bumps in a rough road that you don't really feel inside the vehicle. To address the long-term variation, I've drawn inspiration from the charger for your cell phone, where we can use 120 volts to power a device that runs on 3 to 5. And that's allowed us to really reduce the size and cost of these systems. So with the work that I've done to understand the design, we're bringing the costs of the levelized cost of water down at the same time that we're bringing that technology forward to deployment.